Hi, I'm Brad Vazalis, founder and chief medical officer for endOclear LLC. My career has been as a cardiothoracic, vascular, and trauma surgeon, and I always took care of my own patients in the intensive care units. Several years ago, when I started doing percutaneous tracheostomies, I noticed that the endotracheal tubes that we removed often had so much retained debris and secretions that it would be impossible for a patient to pass a spontaneous breathing trial due to the high resistance. And then I noticed that right after doing the tracheostomy, we would often be able to wean that same patient within 24 to 48 hours. The difference clearly was more than just the length of the tube or the difference in the dead space. A second observation that I had was that there were many patients who I thought could be weaned from the ventilator based on their lung status, their age, their comorbidities, and yet they wouldn't pass their spontaneous breathing trial. And often when we would finally get those patients extubated or trached, I would look at those tubes and would see that a lot of them also had a significant amount of obstruction from retained and coalesced secretions. So today, what I'd like to do is to give you a demonstration and a comparison of different techniques for keeping the endotracheal tube clean. I want to show you why the current standard of care, which is closed suction, is inadequate and what we can do better. Marvin the mannequin has been intubated with a subglottic endotracheal tube that has an inside diameter of 8.5 millimeters. He's attached to the ventilator and a standard closed suction system. What I've done is placed within the endotracheal tube the synthetic secretions, debris, and biofilm-like material that we used in our other demonstration. It's a material that is very viscous, quite similar to mucus and secretions, but if anything is easier to remove by suction than the standard pulmonary and tracheal secretions. So what I'm going to do now is to make a pass with the endotracheal closed suction system. I've placed it in so that the markings on the suction catheter match up with the markings on the endotracheal tube. The suction is at 180 millimeters of mercury, which is standard for use in this application. And I'm now going to apply the suction to the catheter and withdraw it back into its sleeve. I'm now going to insert the catheter yet again. Again, utilizing the markings to line up the catheter with the endotracheal tube. We'll then open the suction to the catheter and remove it. Upon insertion of the scope, we begin to see some of the landmarks on the inside of the endotracheal tube. We're now coming up on the vocal cords, the balloon of the tube, and now we see some of the retained secretions following suction. We're passing through the secretions, show the carina, the tip of the tube, and then pull back through the secretions that remain. We're now backing out of the endotracheal tube, and we'll see some residual secretions as well, proximally. Now we're going to clean the same tube that's been cleaned twice with the closed suction system using the endOclear device. First, I'll take the endOclear BCA adapter and insert that between the endotracheal tube and the ventilator circuit. Next, I will measure the depth of insertion marker by matching up the markings on the endOclear device with those on the endotracheal tube. This prevents overinsertion well beyond the end of the tube, which could be potentially dangerous. I'll now apply a small amount of surgical lubricant to the end of the endOclear device and insert it into the BCA adapter. We'll then put this down the endotracheal tube up until the blue stop is encountered. I will then release the safety toggle so that we can deploy the cleaning member. I'll firmly support the endotracheal tube at the patient's mouth. We'll deploy the device and bring it back into the BCA adapter. The BCA adapter is then disconnected from the endotracheal tube, and the specimen within can either be discarded as biohazardous waste or sent to the lab for microscopic evaluation. Introducing the scope after cleaning with the endOclear device again shows the inner landmarks of the tube. We're now approaching the vocal cords, the endotracheal tube balloon, the Murphy eye, and the tip of the tube. Beyond is the carina and right and left mainstem bronchi. As we pull the scope back, we see that the residual secretion and accumulation following closed suction use have now been removed. Retained secretions, debris, and the formation of biofilm cause several problems for the intubated patient. First, these secretions do obstruct the lumen of the artificial airway. And we know that the resistance increases in patients who have retained secretions. That increases the work of breathing and can delay liberation from the ventilator. Secondly, the retained secretions and debris are the building blocks for bacterial colonization, often by pathologic organisms, as well as the progression of biofilm within the tube. We see by the demonstration that closed suction is inadequate to remove these secretions back to the inside wall of the endotracheal tube. endOclear can do this.